Hi! Today we're going to learn about calculating derivatives of polar equations. Let's say we have to find the formula to compute polar derivatives. How do we do this? Well, first off, we know that a polar equation is written in the form of r is equal to something in terms of theta. An example would be r is equal to 5 theta. Now if we just take the derivative of this, like we would for a regular function, in the Cartesian plane, we would get dr d theta is equal to 5. But what is a derivative? Well, a derivative is dy dx. It's written as dy dx. And even when we're dealing with polar equations, we still want dy dx. So that means that this is not the derivative. So we don't want dr d theta, because that's not going to give us the derivative. We want dy dx. But how do we find dy dx if in a polar equation we don't have any x's or any y's? Well, let's go back to when we learned about polar equations. We learned that there are two main formulas, or two main equations that convert polar equations and rectangular equations, or that it convert polar equations to rectangular coordinates, or equations. We know that x is equal to r cosine theta, and we know that y is equal to r sine theta. And this should make a little bit of sense because we know that on the unit circle, cosine relates to x and sine relates to y, so that's one way to memorize it. But how do we get dy dx? Well, that part's a little bit simpler. If we go back to when we learned about parametric equations, we're going to do something similar. So we know that when we have x is equal to r cosine theta, it's actually x is equal to some function in terms of theta. And because even though we have this r here, we know r is a function that can be expressed as something in terms of theta. So x is equal to a function in terms of theta multiplied by cosine theta. So that means that this entire portion is in terms of theta, meaning that when we take the derivative of this, like if we take a derivative like this, which isn't a really derivative, but let's say we take the derivative of this, we're going to get dx d theta. And if we take the derivative of this, we're going to get dy d theta. And we know from parametric equations that dy d theta over dx d theta equals dy dx. And this is because you're going to multiply by this reciprocal, so you're going to do dy d theta times d theta dx, which gives us dy dx. So let's do that. So the dx d theta, or let's first do dy d theta. And we want to find dy dx. So dy d theta is equal to, we have r times sine of theta, so we just use the product rule here. So the derivative of r is just dr d theta, because we're taking it in terms of theta. And so first to memorize this, or actually we'll move it up here to get more space. So we know x is equal to r cosine theta, and y is equal to r sine theta. And now let's erase this part. And take a moment to go over this, because now I'm going to have to erase this also. So dy d theta is equal to the derivative of r, which is just in terms of theta, which is dr d theta, times sine of theta, plus r times the derivative of sine of theta, which is cosine theta. So that's what dy d theta is. Now let's figure out what dx d theta is. Dx d theta would be dr d theta times cosine theta. So dr d theta times cosine theta plus r times the derivative of cosine theta, which is negative sine theta. So we can just change this sign to a minus sign, minus r sine theta. And there we have it. We have dx d theta and we have dy d theta. So now to find dy dx, we just divide this from this, or we divide this by this. So we get dy dx is equal to dr d theta times sine of theta plus r cosine theta over dr d theta times cosine theta minus r sine theta. So the answer to this problem is the formula to compute polar derivatives is dy dx is equal to dr d theta sine of theta plus r cosine theta over dr d theta cosine theta minus r sine theta. Today we learned about calculating derivatives of polar equations. Thank you for watching this video.